Now it's time to introduce our speaker. Today, we will hear from Dr. Víctor Naranjo. He obtained his BS degree in agricultural sciences from the Escuela Agrícola Zamorano in Honduras. Later, he obtained an MSc and PhD in animal sciences at Louisiana State University. Víctor is currently Evonik's technical director for Latin America and is based in Guatemala. In 2011, he had joined Evonik Ecuador as technical manager for the Andean region and later on for Central America and the Caribbean. From 2016 to 2019, Víctor was responsible for poultry nutrition research in Evonik, Germany, with projects focused on optimization of the ideal protein concept, crude protein reduction, and requirements and bioavailability of amino acids. Dr. Naranjo is a very well-published researcher, and we are honored to have him joining us today. Please help me welcome Dr. Víctor Naranjo.
Dr. Martin, thank you very much for the kind introduction, and also thank you, PSA, for the opportunity to participate in this important webinar. It's really an honor for us to share with you some of the insights and experiences we had regarding the implementation and the development of the potential of reduction of crude protein in broiler diets, and I will focus with some of the experiences we had in Latin America. So what I had prepared for you today is basically we will first go through why it's important to optimize dietary nitrogen levels in poultry diets. Why is this topic currently being heavily researched globally? What are some of the findings we had in terms of literature review and also some of the research collaborations we had with different partners around the world? And in here, unfortunately, due to time limitations, we will not be able to go through all of the findings, but basically the main idea is to show you what are the trends and what are the directions that we are going in trying to find what are the missing points or what are the key points that are related to the reduction of performance at a certain point as we reduce protein. And then there is a gap between what is known today by research and also what is being commercially implemented basically in Latin America. So we will try to connect what are some of the challenges that probably we have seen under commercial conditions for a complete implementation of this concept, because again, there is a difference between what is known by research, what can be done potentially on reduction of crude protein, and what is today achieved in different production conditions. So why is this topic of relevance for the industry? Basically, here you can see some of the challenges we are facing as a poultry industry, which are related to sustainability, livestock processing, and consumer demand. In terms of sustainability, we are always being requested, or we have the pressure to increase our efficiency of production in terms of having less resources to produce more output. And that is related also to less emissions of nitrogen, phosphorus, and other nutrients, and also having or developing the flexibility to use different alternative protein sources. These alternative protein sources is a topic that is of relevance in different regions, depending on the regions, the importance. But certainly we need to have more flexibility in terms of feed formulation and using alternative feed ingredients. In the same way, we are always under pressure to reduce feed costs or optimize production cost while maintaining a good management of diseases and also producing broilers with a good health management, also in an environment where we have reduced AGPs and also the target to reduce the use of antibiotics, while maintaining also meat quality and also improving our prediction of the type of product that we want to deliver to the specific markets we are attending. And at the same time, we want to also meet the consumers' demand, which are evolving related to animal welfare, reduce AGP, and producing healthy and traceable foods. But for all these challenges, we see that a more precise amino acid nutrition is certainly contributing to solve some of these issues. It may not be the complete solution, but certainly contributes to solving or to achieve some of these. To have an overview to a basic model we are doing in animal nutrition. when we are formulating diets, we are providing a set of nutrients that we want to be we want them to be efficiently converted into the final product. If we do this conversion very efficiently, eventually nutrient excretion will be reduced. So if we take that as a model, we say that nutrient excretion is related to the nutrient intake and the nutrient retention. And if we want to optimize the utilization or reduce the nutrient excretion to the environment, basically we need to optimize nutrient intake and we need to maximize nutrient retention. So what we can do to reduce nutrient intake, or in other words, optimize nutrient intake? One practical and probably underestimated concept is to reduce the safety margin in raw materials and feed specifications. In practice, we see that raw materials loadings in feed formulation software sometimes are not very commonly updated, and there are some opportunities to reduce nitrogen content in the diets by optimizing the frequency of loadings in the raw materials by having a good quality control and using correct nutrient analysis of the specific loads of raw materials we receive. And at the same time, by having a good control of the raw materials, that will help us to also manage feed specifications safety margins, which are in some cases applied in feed formulation. We have seen that in some cases, there are used some safety margins for the feed specifications just to counteract for any variability that we can have on raw materials. So this point is certainly something that we can do a lot to try to reduce nutrient intakes. We also need to work on precise nutrient expressions and evaluation of the raw materials. That meaning that sometimes we have different expressions of nutrients in the loadings of the nutrients and in the specifications of the nutrients as a requirement. And there are several methods, and this applies not only for digestibility, but also for example, for phosphorus, for energy. There are different ways to express the nutrients, different methods, and we have a lot of opportunities to have a very concise methodology to optimize the expression of nutrients and the specifications. And this will help us to reduce excess nutrients in feed formulation, and in nitrogen specifically, which will be the topic of my presentation. We have a lot of opportunities to reduce these excess nutrients through the use of supplemental amino acids. This on the nutrient intake part. On the other side, we definitely need to do alternative or do approaches to increase the nutrient retention by the bird. And by doing this, we can certainly increase the diet digestibility. There are different alternatives to increase diet digestibility through additives or through good selection of raw materials, or having a good evaluation of the different suppliers of different raw materials. Appropriate feed additive selections to improve performance and health that will help us to increase the retention of nutrients, and reduce all sources of stress, which will deviate nutrients from growth into other maintenance requirements, which will reduce the retention of the nutrients into the final product. Again, here mentioning, for example, factors such as management, environmental conditions, and health. Focusing on how we have evolved on crude protein and amino acid nutrition throughout the years, we can see here in the slide that before the 1950s, it was believed that protein was needed for a correct nutrition or a correct growth of the animals. Eventually, there was more knowledge on the amino acid composition of the raw materials. It was known that protein was composed of amino acids, and then the concept of and the technology at the labs also to determine total amino acids in different raw materials was developed. A good database was started to being constructed. And then also the concept of digestibility was developed. Not all the amino acids that are contained in the raw materials are available at the same proportion or at the same degree. And then the concept of digestibility was developed, and today it's widely used in formulation of diets for poultry. Also, the application of the ideal protein concept has been widely accepted and applied in poultry and swine. And today, this offers a lot of opportunities to continue further optimizing feed formulation. And I will go through what does the ideal protein concept means in a second. But now we are also in an age where we are trying to understand how dynamic the ideal protein can be, how dynamic the ratios can need to be changed depending on the conditions, and also as more knowledge is developed regarding the functional roles of some of the amino acids. And all this knowledge has been developed as the supplemental amino acids are starting to become available. And as more supplemental amino acids are available, also there's more opportunities for further reducing protein or further reducing the content of intact protein sources. All of this has been done, again, by the application of the ideal protein concept, which in general establishes that there is a perfect balance or need of amino acids for protein deposition. And in practice, it means that we need to establish an optimal digestible lysine level depending on the parameter or KPI that each company wants to optimize, depending on the economics of each company, on their process, if it's either live weight or final carcass or cut or FCR. Depending on the different parameters they want to optimize, they need to establish the optimal lysine level. And once the lysine levels is established, we apply the ideal protein concept, in which all the other amino acids are maintained at an adequate ratio in relation to that lysine level. When doing this approach, one of the key opportunities for further optimizing or reducing the excess of nitrogen is that we should eliminate the crude protein restriction as long as we maintain the specifications of all the essential and key non-essential amino acids that we need to control in feed formulation. That will allow the crude protein level that we are capable of reaching with the availability of the current amino acids. And in general, with the ideal protein concept, we have two approaches that are being widely investigated in different places and during the last years. Basically, on the one hand, we had the increased balanced protein levels, which means that we will increase the lysine content of the diet, the digestible lysine content, and as a result, all other amino acids will be maintained at a specific ratio, and as a result, protein levels will increase. What we expect from performance when increasing the balanced protein level is that basically performance will increase, FCR will reduce, and carcass traits will also increase. And this has been seen in several trials. We have done a lot of experiments also recently on this topic, where we see that modern broilers are highly responsive to increasing levels of a balanced amino acids. But what we have seen also is that as we increase the density of amino acid in the diet, certainly this drives for more efficiency. But in terms of nitrogen utilization, this is rather unchanged. So if we really want to improve or increase nitrogen utilization, the other approach is crude protein reduction, which is expressed here as, for example, today we have a diet that is being supplemented only with 3 amino acids. That means that the other essential amino acids are relatively in excess or higher than the amount required. And as we increase the amount of the other essential amino acids being supplemented, we are starting to meet the requirement at the specific level, so at the 100%. This drives protein lower or reduces protein level in the diet because the intact protein source, mainly soybean meal, is being reduced, while supplemental amino acids start to increase, and also starch or corn will increase for making up the space of feed formulation. What we expect when we do this strategy is that we are able to maintain performance without affecting performance or body weight gain or FCR. But what we have seen is that certainly reducing this excess of amino acid, it will increase nitrogen utilization. So this is what I will focus in this presentation on. What are the challenges that we have seen on the experiments when we reduce protein, looking into or trying to achieve for higher nitrogen utilization. But why this topic in particular also is being highly investigated again is because it offers also, in terms of performance, a lot of potential benefits associated with the reduction of this excess of protein. On the one side, depending on the cost of the raw materials and also the next limiting amino acids, there is some potential for feed cost savings. Again, this depends on the cost of the supplemental amino acids. It certainly goes in favor of a more sustainable production in which we can reduce significantly the amount of nitrogen and ammonia emissions from broiler operations. And today, this topic of sustainability is gaining more relevance in different parts of the region, and even in Latin America. For example, some countries which are exporting broilers, they are becoming more and more interested on the topic of how they can work on sustainability on their diet, meaning how can they reduce the CO2 equivalents of their diets by having different feed formulation strategies, such as reduction of crude protein. So this is a topic that is probably today underestimated in some parts of the world, but certainly will gain more interest. And there are a lot of strategies and tools that can be used to monitor the sustainability approaches that we are doing when implementing more advanced feed formulation strategies. As we reduce the excess of protein in the diet or the excess of nitrogen in the diet, we also have seen that we can improve the litter quality or contribute to achieving a better litter quality. And in consequence, we have seen less incidence of foot pad dermatitis. So also we see that this can contribute to animal welfare. As we also reduce the excess of nitrogen in the diet, we have seen also that there is less nitrogen substrate for pathogen proliferation, which is also an important factor or an important strategy that can be combined with the use of different additives when trying to develop feeding concepts AGP-free. So reducing this excess of protein can certainly support this approach. By reducing the excess of protein, also we are reducing water to feed ratio, where in some parts of the world, this can have a significant impact. But we see that as less excess needs to be catabolized from the body, there's less water intake. And because protein has the highest metabolic heat, we see that a reduction of this excess of protein can also contribute to less metabolic heat and can be used as a strategy for heat stress feeding. And again, focusing on the amino acid nutrition or focusing on the amino acid needs certainly will bring us more flexibility regarding formulation and the use of alternative ingredients. So these are some of the benefits that we have been associated with the reduction of crude protein. However, there's also some of the challenges that there is a point or a break point or a threshold where performance is lost. So what we have done is one of the first steps was to look into the literature of crude protein reduction to try to understand what are the main ideas or main factors that are related to the reduction of performance. This was first done in 2007 by Payne, where he reviewed the data available at that time and compared controlled diets or conventional diets to low crude protein diets. And at that time, he also concluded that protein levels can be reduced in broiler diets by 3 to 4 points, while correct and adequate levels of supplemental amino acids are used. However, in this review already, there were some experiments that also failed to maintain performance. And we were trying to understand why in some cases, or where is the limit on the protein reduction. So based on that, Andreas Lemme did a very nice review, taking into account data published from 2000 onward, and trying to understand what are some of the limiting factors on the reduction of crude protein. And this paper is available. We can share it anytime with you. Also, it's available in the internet, and it's highly recommended because it's a very nice overview of data, again, since 2000 onwards. What were some of the key findings that Lemme and Rodriguez reported in this publication? First, they reviewed the literature as it was published, and one of the main findings was that many experiments were conducted from a feeding phase of 0 to 21 days. And in those very long starting feeding periods, most of the experiments, or a good number of experiments, failed to maintain performance. When they splitted that data set into more shorter feeding phases, they saw that the performance was possible to maintain. It was much easier to maintain performance when feeding phases were shorter, especially during the starter period. So certainly establishing a phase feeding program is a prerequisite for successful crude protein reduction, especially also in the starter diet. Very long phasing periods with crude protein reduction may fade to maintain performance. And in some parts of the world, sometimes this long feeding phase may be used, but certainly if we want to increase the precise nutrition, we need to move to more phase feeding programs. Nitrogen utilization was increased with crude protein reduction, but as you will see later on, not necessarily maximizing nitrogen utilization will equal the best performance. And at some point, depending on the key performance indicators on which parameter each company wants to optimize, but if it's only nitrogen utilization, there may be some trade-off on performance. So there is the very nice opportunity to find this in-between place where each company can decide what they want to optimize. And here you see the data from 22 to 37 days that was reviewed by these authors. And here you can see the nitrogen utilization with the crude protein reduction on the x-axis. And as you can see, as you reduce protein, nitrogen utilization in general was increased. And here, just as a benchmark, that in many situations under commercial conditions, a nitrogen utilization of 55 to 60% is being achieved. But certainly, as we reduce protein, we can increase this nitrogen utilization. And there's great potential to increase under commercial conditions nitrogen utilization with just some few improvements or reductions on protein. And here on FCR, you can see also the red line represents like a benchmark for the genetic guideline. And many experiments were able to maintain a very good performance while compared to the genetic guideline, while maintaining performance with a reduction of protein. So also what this publication did was that instead of looking at the overall trends of all the publications, what they did was to have a closer look to those experiments that were able to maintain performance. So basically just to have a closer look at what all of them had in common. Instead of just looking into all the experiments and as a trend. And I think this was very good approach because it helped us to develop some of the factors that were common for maintaining performance. And some of the learnings in these publications, when specifically looking into the grower finishing and overall feeding program, was that the ratios to lysine that maintain performance were listed were around these levels. So you can see it here. Some of the publications that were able to maintain performance were around these levels. So basically, we need to maintain a good balance of the essential amino acids and also monitoring the levels of glycine equivalent or glycine plus serine. Here in my presentation, I will be focusing on glycine equivalent, which is the serine times 0.71 because of the interconversion of these two amino acids, and we will report them as glycine equivalent. But certainly you can work it with glycine plus serine or any other form. Yeah, but you can see here that based on or focusing on these specific experiments that were able to maintain performance, we were able to reach some of these levels of ratios that were maintained. Important learning also from all of this is that in many cases where performance was not maintained, also it was related probably to some specific factors of the experiment, and in many cases also diet analysis of the diet was not reported. And I will also address this topic later because as we move on precise amino acid nutrition or a more level or a more or less surplus of excess or less excess in the diet, we have less chances to make errors when formulating or when producing the diet. And sometimes this is not always reported. And also we have seen that in many commercial applications, this also becomes a big challenge. So taking this into account, also Leme did a very practical crude protein experiment in Germany following these guidelines, where he used 5,000 broilers using pens of 250 birds per pen, so trying to simulate a more commercial condition. They also follow all the regulations on the number of animals per square meter from the country. Each pen was equipped also with 4 bell feeders and also the same number of drinkers. And something interesting was that the amount of bedding material was also measured at the beginning of the experiment. So all pens received the same amount or the same volume of liter, as this was also measured at the end of the experiment. Temperature and lighting program was following the practice in the country. And also here you can see the protein levels that were fed in the experiments. The feeding phases was the starter, grower, finisher. The duration of the experiment was from 0 to 40 days. And basically here you can see that in the starter diet, basically protein was not heavily reduced, was actually maintained similarly across treatments. And then in the grower and finisher, protein was reduced in a stepwise manner with the inclusion of the next limiting amino acids. In general, what we saw was that as you reduce the protein level, you will reduce the nitrogen intake as expected. And if we express these results as relative to the control diet, which is already a low level of protein, or depending on, low is a very ambiguous term because it depends on where you are based, but on a very good levels of protein, which is the standard in Germany, you can see that a small reduction in the crude protein level of the diet had a huge impact on the nitrogen intake and also on the nitrogen excretion. For example, with the first level of reduction of protein, we were able to reduce 9% the protein reduction, the nitrogen excretion, and by 19% when at the second level of protein reduction. When looking at the performance, you can see here that basically body weight, feed conversion, mortality, everything we were able to maintain as protein was reduced up to the third level of reduction, or what we call the medium nitrogen reduced diet, and also it was increased the profit of this diet. But at the lowest level, or the strong reduction of protein, we started to see some problems on FCR. Basically, FCR started to increase. But some of the additional benefits that were obtained with these moderate reductions of protein was that the liter volume, again, if you remember, we measured, or we weighted the amount of liter that was distributed in each one of the pens. The amount of liter volume was reduced with the third level of, as we reduced the protein level, and also the amount of humidity. So meaning that reduction of crude protein was also able to increase dry matter liter, or dry matter in liter, or reduce humidity in the liter. As a consequence, if we see here the distribution of the degrees of food path dermatitis, we see that as we reduce the protein, also we had better quality of food path dermatitis, or less incidence of food path dermatitis as we reduce the protein levels. And this has been also seen in many experiments. Again, we have not too much time to go through all the data, but this has been consistently seen in many of the experiments that have been done in a similar approach with more a commercial application or a commercial setting. But certainly, we can reduce protein, maintain performance while improving flocks' health, welfare, and sustainability. But there appears to be a threshold or a point where FCR starts to increase, and also abdominal fat starts to go up. So there is a limit, that today the research has also not been able to find a solution of why performance is dropping further a specific threshold. So here is some of the insights, or some of the things that we have been doing on trying to understand why performance is going down at a certain point. And one of the first things we did is what is going on with the diet composition in general. And as you can see, as we reduce protein, and here is a comparison between a diet of 20% and a 16% crude protein level. This is a very extreme protein reduction, but just to maximize, or to better illustrate the effects that we can get. We certainly increase the amount of grains, the amount of corn. If we are in Europe, this will be wheat, but we increase the amount of grains. We reduce the amount of intact protein sources, which will be mainly soybean meal. As more grains are being included, there will be less vegetable oils, or oils added to the diet, because there's more energy coming from corn. And the amount of supplemental amino acids in some is also increasing drastically. Protein is reduced, fiber is somehow also reduced, depends. Total lipids is being reduced because there's less oil. the amount of starch is increased. If this is not controlled, potassium will go low. Dietary electrolyte balance also will decrease because of the less potassium being supplied by the soybean meal. And the starch to lipid ratio, if we look into the macronutrient, start to increase. So what we see is that there is, as there is a severe reduction in the protein, there is also a very severe change in the macro composition of the diet that sometimes is not being considered in many of the experiments as we reduce protein. Here we can see starch is going up, lipids are going down, and basically there is a complete different macro composition of the diet as we reduce severely protein. And what we have been doing is basically look into all these amino acid limitations, and this has been done also by several researchers in looking or trying to identify the ideal amino acid profile, what are the specific ratios as we reduce protein, what is the interaction of branch-chain amino acids, excess leucine, isoleucine, valine, what are the needs of glycine plastering. All these topics are being heavily investigated, and there's a lot of information on this and the balance of essential and non-essential amino acid as a good parameter to be able to derive what is the lowest level of protein that we can reach under commercial conditions. But also, as I mentioned before, there's some non-amino acid limitations that are sometimes overlooked, and we try to also take into consideration in some of our experiments. Dietary electrolyte balance have also been investigated before, but as we mentioned, this is also changing. Potassium content is being reduced. Phytate levels are going down also as we reduce soybean meal. So what is the phytase efficacy? Crude fiber, is GISAR functionality being impacted? Supplemental amino acids also started to increase, and one of the topics is how accurate is the dosing in the feed mill. And you will see, I have a slide on this, but this is some of the main challenges we have also when we move into commercial application. As we start to supplement the next limiting amino acids, which will be added in less quantity, the precision needed at the feed mill also increases. Even in many research experiments with different partners around the world, sometimes just having a close difference between what is being formulated and what has been analyzed is a big challenge. So imagining this under commercial conditions. So this really becomes a challenge that needs to be followed to really move to the more precise nitrogen diet. Added fat is reduced, starch increase. So we need to understand more of this starch and protein digestive dynamic concept that is being developed by several researchers, but also very heavily by the University of Sydney, also working with Peter Crystal and Peter Selly and Sonia Liu. They have been working in this concept, and we develop a research program with them just to have a focus or have a better understanding on what is the role of low crude protein diets on animal performance, what is the impact on fat deposition, FCR, weight gain, what is the effect of different type of diets, what is the effect of crude protein reduction in corn-based or wheat-based diets, what is happening at the physiology and the digestibility of the amino acids as we reduce protein, and also this digestive dynamics concept. And what is the impact of the different crude protein reduction levels, basically with interaction of several key amino acids as glycine equivalent, threonine, branch-chain amino acids, and sulfur amino acids. So I would like to share with you some of these insights of this program or this collaboration we had with Sydney, which also complements what I have been mentioning before on the findings that we had on reduction of crude protein. So here, each one of the bars represents one of a trial, which was basically similar in structure or similar in design, where we do titrations of crude protein reduction while maintaining the amino acid ratios that we have been talking before. The line on top represents the average of these three experiments. And as we can see here, and all experiments are from 7 to 35 days of age. The starting phase, all broilers were fed the same common and adequate diet. So here, as you can see, we were able to maintain performance up to 17% of protein reduction. And as we reduce to the 16% level, body weight gain was depressed, and also FCR started to increase. And this was consistently seen in all experiments in which we were able to maintain performance up to this level of protein reduction. But even if we maintain, and we tested several strategies at this diet, we were not able to maintain the performance at this level of protein reduction. What we see also is that as we reduce protein, we have an increase in abdominal fat, and this becomes more evident as the reduction in protein becomes more severe. Amount of abdominal fat increases. But in all these experiments, as we reduce protein, obviously, we increase also nitrogen utilization. In all these experiments, we did the digestive dynamic concept that this university is heavily working. So we also correlated this starch to protein disappearance rate at the distal ileum to the increase on fat pad. And as you can see, basically, I will focus first here on the right, that you can see that as we increase the amount of fat pad, the feed efficiency was correlated with reduction. That means that as we had more fat deposition, the efficiency, or the FCR of the broilers, was negatively impacted. And when we look into the fat pad weight, these were also correlated with this starch to protein disappearing, meaning that as more starch was included into the diet, there was more fat deposition, and this was also probably explaining some of the responses on the lower FCR. So this is a concept that we are also exploring and trying to better understand, but it seems that is also some other factors more than just amino acid limitation need to be considered as we go further down on protein levels. So macronutrients may also play a role. Digestive dynamics may also play a role here. And here, just an experiment with this university also, where we tested the concept of adding more threonine or glycine plus serine, or the combination of both. And what we found, again, was that we were able to maintain performance here up to the 17%. The 16% already had the lowest body weight gain, and FCR was increased. When we increased the digestible threonine to lysine ratio, it did not help too much. Also, increasing the glycine plus serine alone did not help too much, but the combination of both the strategies were able to maintain performance similar to the standard diet. So this is something that also we are exploring more into detail. And based on that, also here are some recommendations that we have developed based on some of these experiments. Basically, as we reduce protein, we need to take into account also threonine ratios that we are managing, arginine to lysine ratios, and certainly start monitoring or monitor our glycine equivalent levels in the diet. You can see here that the requirements are reduced. This glycine concept is also a specific topic for a presentation on glycine, as glycine is affected by several factors. But as we reduce protein, we certainly need to monitor glycine equivalent levels in our diets. And also, again, keeping in mind that the ideal protein concept is dynamic, and that some amino acids may become more relevant as we reduce protein, and some ratios of amino acids may need to be increased. And basically also here in branch chain amino acids, we have seen that in practice, for example, different ratios are being used. But as I show in the review done by Leme, there were some consistency in those experiments that were able to maintain performance, which maintain a much higher level of these branch chain amino acids, specifically valine and isoleucine. But what are some of the commercial challenges we have seen in Latin America in the implementation of this concept of reduced protein? Certainly, what limits us today to reduce further protein is the availability and the feasibility in terms of cost of the next limiting amino acids. There's nothing we can, there's not too much we can do to further reduce protein if we do not have too much availability of isoleucine, arginine, or even glycine. So this is some of the limitations, and in some cases, when the amino acids are available, sometimes feed costs will go up, and probably this is one of the main reasons why this concept is still not yet highly implemented under commercial conditions. In general, there are several companies that are looking for more reduced protein because of the associated benefits it comes. and they also invest into this reduction of protein. But certainly, as these supplemental amino acids becomes more available and also more feasible, protein levels will certainly go lower. There's also the need to develop more confidence to eliminate the crude protein minimums in feed formulation. That there is still some distrust or some more conservative approach of not reducing or not eliminating the crude protein minimums. But we specifically try to provide all this technical information to make sure that as long as we maintain appropriate ratios of the amino acids, we will be able to maintain performance. And we need to have a specific follow-up on the branch chain amino acids, threonine, arginine, glycine equivalent ratios. Also, an important parameter or something to mention here is, again, that immune stress may call for extra nutrients or will call for extra nutrients and energy. And as we reduce protein, we certainly have less surplus of nitrogen or less excess of these amino acids. And that's why we need to consider this functional role of amino acids and the importance of maintaining this concept of dynamic ratios. We need to understand that under some situations, it will make sense to increase some ratios of amino acids. And here, there's a lot of opportunities that will help us to maintain performance. But under more practical conditions also, not just on the levels, but also in the implementation of the concept as we develop the diet, one of the key aspects in Latin America is that we have to manage feed ingredient variability. We receive in some countries, for example, ingredients from different origins that are variable in composition. For example, some countries will receive soybean meal from US, from Brazil, from Bolivia, and obviously the content will change, and they need to have a system in place that will manage this feed variability or this nutrient variability. But also we need to have a very precise dosing and mixing of those amino acids while maintaining, as I mentioned before, the optimal ratios. Here, an example of the analyzed levels of crude protein and total lysine levels on the y-axis of different soybean products. Just to denote the variation that we can see here in Latin America. And here are samples of soybean expeller, and soybean meal, where you can clearly see that not all soybeans are created equal. Here you can see that the 47 protein soybean meal may not be always the same, and that here are the variability on the total lysine content. And this is related to precise nutrition, not too much on the specific, if it's 76 or 78 or 80 of valine to lysine ratio. Here is just how we can improve or reduce the difference between what is being formulated and what is being produced as an output in the feed mill. And this occurs at all levels of protein, and basically how we can close this gap. But also in Latin America, and specifically, we also use a lot of full fat soybean meal in some countries. And this becomes a challenge because sometimes soybean meals are not well processed, and we need some methodologies and we need some systems in place that will help us to control the quality or to know which type of ingredients we are working with. Here you can see some of our research on the impact of overprocessing of soybeans or soybean meal. As you can see that as we overprocess soybean meal, we will have a reduction on the digestibility of lysine, and also the same will happen, but in a different behavior or in a different manner as we have underprocessing of the soybeans. And if we are formulating on digestible levels, then we can have underestimation or overestimation of the levels that we are reaching. The other part is that as we reduce the content of the intact protein sources, which could be the different ingredients we use, for example, soybean meal with poultry byproduct meals or any other animal byproduct meal, we will have also increased levels of supplemental amino acids. In our portfolio of services, we also have the opportunity to do feed homogeneity test by using the amino acids as a marker. And here are the results we have until June of some of the diets or some of the feeds that have been produced in Latin America. Here are customers from all around Latin America. But here you can see that the CV achieved under commercial conditions by different companies varies a lot. We have companies that have a very good CV on the supplemental amino acids, but some others that have challenges. for having a homogeneous distribution of the mixing of their feed. So as we reduce the protein, or as we move to more precise nutrition amino acid diets, we certainly need that the homogeneity of these supplemental amino acids can be guaranteed. And this certainly becomes a challenge, but is obviously, and sometimes this factor is overlooked, or probably not underestimated. So certainly quality control of raw materials and complete feed, also the quality control of the complete feed, is essential for precise nutrition of protein and amino acids. And again, we had some recent experiences in the development of a crude protein project with a customer in Latin America, where the main problem was feed manufacturing. It was not related to the diet. The diets were fed to the broilers, and when we analyzed the diets were not close enough to what we formulated. So basically, the challenge of formulating of producing the diet very similar to what is being formulated is certainly a challenge that needs to be addressed. And what is not defined cannot be measured, and what is not measured cannot be improved. And this related of the importance of the quality control lab, and that this information is what will help us to move to a more precise amino acid nutrition. So just to close up, again, crude protein reduction without compromising performance is possible. There's a lot of room for protein reduction in Latin America. We have the opportunities to reduce protein while maintaining a good performance, but we need to take into consideration our ratios of amino acid. We need to eliminate the crude protein levels. We need to monitor our glycine equivalent or glycine plus serum levels in the diet, and depending on our specific conditions, define which ratios of amino acids are best for our system. Raw material and feed production, again, as I mentioned just recently, is key. We need to make sure that our process is correct, that we have a very good system of nutrient loadings, that we have identified the variability of our raw materials, and that we have a system in place that helps us to control that the final product is similar to what has been formulated in paper. By maintaining this, we can maintain performance, weight gain, feed conversion, as we reduce performance with the availability of the supplemental amino acids we have today. Small reductions of protein per se will have a huge impact on nitrogen excretion. And nitrogen excretion can be decreased, and there is a general rule of thumb that 1 percentage point of crude protein reduction will reduce in 10 to 12% nitrogen excretion. So conservative protein reductions will certainly have a huge impact on nitrogen excretion. We can also contribute to less water consumption, or improve physiology by having less excess of protein that needs to be catabolized by the broilers. And that will result on also a factor that contributes to better litter quality. And by having better litter quality, again, this is just a factor that contributes for a better litter quality. We know it's multifactorial, but by doing that, we will certainly contribute to have less incidence of foot pad health, less incidence of foot pad dermatitis, and also contribute to a more gut health program. So there are certainly good opportunities for crude protein reduction, but there are some key factors that still need to be considered for having a good implementation of this program. So this is what I had for you today. I hope I did not took too much time, but open for your questions. Thank you again for the opportunity.
Thank you, Dr. Naranjo. That was an excellent presentation. Very comprehensive and very clear. So thank you very much. We do have a couple of questions in the Q&A window. I put the question is in Spanish, so I don't know Spanish, so I used Google Translate, and I understand most of the words, but I will read it as I understand it. And if you can see the question, you can also put your correction in the twist that I might have put on it. So the comment was, first, excellent presentation. How do you get an adequate level of cysteine in the methionine plus cysteine relationship, i.e. greater than 75%, without affecting the methionine ratio, 40 to 43%, due to low levels of cysteine in the feed? Is that a
Yeah.
clear enough question?
Yeah. Yeah.
Okay.
No. Yeah. We have done several of these experiments also, in which we took the 16% protein diet, also by increasing the methionine plus cysteine ratio with DLM supplementation, meaning with only methionine, with increases the methionine to the methionine plus cysteine ratio. And in that sense, it was not really limiting the performance. We have seen that up to 50% of that requirement can be met by DL methionine without affecting the performance. So this was really not impairing. And also we did not see a further improvement of going much higher on methionine plus cysteine in reduced protein diets. We also tested this because we thought of the methyl donors needed as we reduce protein, but we were not able to also to compensate for the performance loss with the increased ratio of methionine plus cysteine.
Okay. There's a follow-up. I'm not sure if it's clear enough, but glycine equivalents, how do you interpret those?
Yeah, that's different ways of expressing glycine plus serine. We can say glycine plus serine, digestible glycine plus serine, or you can convert the glycine plus serine as glycine equivalent. For that, you will take the serine level and multiply it by the intramolar conversion factor of 0.71. So that will give you a single number, which is glycine equivalent. But it can go either way. I mean, we can report on glycine plus serine or glycine equivalent. But the ratios that I show in this experiment are based on glycine equivalent. So we have taken this calculation of glycine plus serine times 0.7143.
Okay, thank you. I don't see any more questions in the Q&A section. I do have a couple of questions. As you may know, I work in the area of precision feeding. Precision nutrition is very interesting to me. Do you do any research in the area of quantifying individual animal requirements? And well, how much do individual requirements vary?
Yeah, this is a very good question, Doctor. And also this is something we have discussed, for example, when we determine requirements and specifications for feed formulation. Because in some approaches, for example, even when we do the statistical approach to determine the requirement, we need to consider that we are feeding the populations per se. So probably what we have seen is that like when we focus on those experiments that were able to maintain that performance, in most of the cases, the ratios that they use for some of the essential amino acids were higher than other recommendations. Probably this was taken up for some of the variation on the individual intake, because we are not able to monitor the individual intake of a complete flock for a more precise nutrition. But when having these increased ratios, this may have overcome some of those challenges, but not too much research on that, but just more on the discussion of which experimental or statistical model better represents the flock than that we are feeding in practice, let's say.
Yeah, you mentioned during an immune response, the amino acid levels vary. There are also presumably different amino acid, either ideal protein or ideal amino acid ratio, or perhaps energy to amino acid ratios that change in animals that are growing at different rates. Do you see a future in our lifetime? I'm probably a lot older than you are, so maybe in your lifetime, for an individual feeding approach.
Yeah, hopefully this is we can achieve something like this, because this will bring us to the next level of precise nutrition. That is a topic that is being heavily investigated. But we did we have a colleague that is actually working very actively on the nutrition and health topic. So trying to understand what are the ratios or what are the requirements of nutrients based on different specific challenge models. And we have learned a lot that, for example, when we do single titration of a specific amino acid, sometimes we fail to see a response to an increased level. But when we take into consideration a combination of amino acids and energy and other factors, we have more chances to get a response, because we see that as immune challenges are there, it not necessarily is a single factor, but maybe the limitation of many others. We have a research program on that, because it will really help us, like you mentioned, how we can derive more precise recommendations based on the specific challenges that the company has. AGP3, they have necrotic enteritis subclinical, or they have litter management challenges, or ventilation or heat stress. But I think that a lot of information is being generated, but it will take time to derive some more concrete recommendations on this. But certainly we are trying to develop something in this area.
Okay. One last question before we run out of time. You indicated in one of your slides, the importance of considering the number of phases that we feed to broilers, because the ratios, particularly of energy to protein, change in terms of their optima. How many phases would you recommend practically, and what are the impacts that you would expect on production and efficiency?
Yeah. Well, we have done modeling, and by modeling, we have seen that the more phases, the better nitrogen utilization. That's clear. Yeah. But then it's practice. What can we really achieve at the